So we've started to talk about combined stresses or combined loads, where we take a number of different methods of loading and we start to put them together. And of course, we're using superposition because we're still in that linear elastic range. And so the net result on our differential element, as far as stress goes, is the net sum of things. And so one of the first places that we looked at, because it offers stresses in multiple different directions at the same time, was pressure vessels. And in this example, we're just going to very quickly look at a spherical pressure vessel. We have two hemispheres. They've been welded together with a weld. And what we want to do is to determine the maximum allowable internal pressure in the pressure vessel, P, given the conditions here. So we have a yield stress and ultimate stress. We have factors of safety for both of those, and of course the geometric properties of the pressure vessel. And what we want to do is determine what that P is going to be. So the way I'm going to go about doing this is I'm going to start by actually determining what my allowable stresses are by applying my factors of safety to the material properties, and then go on and get P allowable after that. So let's get started, and we're going to start by looking for my normal stress allowable. And so we have two that we have to test. And so we start and we go stress allowable is equal to, and it's either going to be the ultimate stress divided by its factor of safety, so factor of safety ultimate, or it's going to be the yield stress divided by the factor of safety designated for yielding. And so we need to calculate both of those. So we're just going to do them up here. So we see that our ultimate is 165 megapascals, and we divide that through by our ultimate factor of safety of 2.1. And we're going to compare that to the yield stress of 110 megapascals divided by its factor of safety of 1.5. And so we come up, we run those through our calculator, we come up with two different numbers. We have 79 megapascals in the case of the ultimate, and that compares to 73 megapascals in terms of the yield. So we have two values. Of course, we need to be conservative, and so the lower limit, because this is a limit that we want to place on it, so the lower limit is going to constrain our behavior, and so we will just identify that as sigma allowable. And I'm just going to annotate that down here to say choose conservative, which in this case is the lesser of the two, just so that people understand what it was that we chose. So now that we know the value for our allowable stress, we can go ahead and calculate what our pressure allowable is. So we're going to do P allowable. And so if you recall from the lecture, we know that the stress in a spherical pressure vessel is equal to the pressure times the radius divided by 2 times the thickness. And so we're going to rearrange that so that we can go P allowable is equal to our stress allowable times 2 times the thickness, all divided by the radius. And so we can substitute in our values. We put in 73 megapascals from the last section for our stress allowable, 2 times our thickness, which is 50 millimeters, and all divided by the radius of 500 millimeters, and that gives us a value of 14.6 megapascals. And I'm just going to highlight that, and that gives us our P allowable. So that's it. It's a fairly straightforward problem. Conceptually, it was in deriving the formula for the stress. That was probably the only place where this was at all interesting. Otherwise, it's a fairly simple application of some of the processes that we've learned along the way. So hopefully that was of value to you. We're just going to get more and more complex as we go through a series of examples on combined loadings. So this was our welded sphere. Our next one up, we're going to start looking at a beam which also has an axial load applied to it, and we're going to get, like I say, more interesting and more fun as we go along. So if you want, there's a link coming up here at the end, not just to the next video, but also to this whole series of problems in combined loading. So if you want to follow that playlist, like I say, we're just going to get a little bit more complex and a little bit more interesting with each successive example.